Here's a video for 8.2, what we're doing today since you guys will be gone, properties of exponential functions. Here's another example that goes along with example 1 in the book. So they're asking you to graph two different exponential functions and then label each graph. Just as similar as yesterday's, you can see they've created a table. Step 1 is creating a table, and then step 2 is graphing those coordinates, those points, on a graph, and then finding the asymptote. So here's the table that's been created for this 3 times 2 to the x, and then also for y equals negative 3 times 2 to the x. They've plugged these x values in and then created the table. They take their points and they plot them. This graph is super small, and I apologize for that, but you can see that it's going to create, this first one is going to create the red line, 3 times 2 to the x, and here is going to be my blue equation graphed. Now we got to find the asymptote. So where do both of these lines approach but never cross? They're approaching right here, and that is at y equals 0. So my asymptote is at y equals 0 for both graphs. These next exponential functions that you're going to graph is going to be a little tougher. Here we have additional, actually get the whole equation, additional things in. So we're used to just seeing and working with yesterday, y equals a times b to the x. Well, now instead of having just this, we're going to add in our plus or minus h, and then also plus or minus k. So here we have y equals a times b to the x plus or minus h plus or minus k. I'm going to give you a brief what this k is. Your k is going to be your asymptote. It's going to be where this function is approaching but never crosses. That will tell you. Over here, my h is going to be shown how stretched out, and it's the vertical stretch or shrink. Okay, so let's just go straight into graphing them. You can graph y equals 1/2 x. What they've done here is they've created a table, which they didn't even show you, but you create a table, plot your points in. Okay, 6 when x is 0, 6 times 1/2 to the 0 is 1, so 6 times 1 is 6. So at x is 0, y is 6. So they've just plotted these points. Now they've created a table. What you're going to do is create another table for your new. And what we know already is that my asymptote is going to be at -2. So let's create it. And h equals k. So k equals -2. So you can see here as they graph this red line, which they created the table for, it's equaling -2 is where my asymptote, where this line is approaching. So we plug in 4 here. 4 minus 3 is 1. 1/2 to the 1/2 is 1. 6 times 1/2. 3 minus 2, can't forget this whole piece here, is 1. So my order pair is 4, 1. So explain that again. I'm plugging 4 in for my x. I'm just making this table. 4 minus 3 is 1. 1/2 to the 1 power is 1/2. 6 times 1/2 is 3. 3 minus 2 to finish this out to equal my y. So y is 1. So you can see here they've plotted 4, 1, and they're creating this graph. You do need to find more points on your table so you can graph. So you created your table, you will get this red line. Now, the whole point is that you'll be able to make this red line, you'll be able to make these shifts from this function alone. So we know we're going to the right 3, and because of this h value being a -3, and now we're going down 2 because it's a -2. So pick any point. We can go over 3, down 2. That's my new graph. Pick a point right here, over 3, 1, 2, 3, down 2, 1, 2. Still hitting that same spot. Find a nice point here. we can go over 3, 1, 2, 3, down 2, 1, 2. So you can create this here graph from this by knowing the shifts. So once again, your asymptote, your vertical shift, we're going down 2, and your asymptote's going to be at -2. And then here we're going a shift to the right, and it's just like with absolute values when we had y equals x plus or minus h plus k. Minus is how we typically wrote it. A negative h, we were going to the right. A plus h, we were going to the left. Same concept. A -3, we're going to the right. If this would have been a +3, we've been going to the left. Our k is going up or down accordingly to the same. Once again, you do have to label your asymptote here. So for this equation, which I know I'm getting a lot in there, sorry about that, is y equals -2. Word problem. 100 mil. Go ahead and pause the video and read it. Alright, now that you've read the video, we know this is the amount. The initial amount we have is 50. The decay factor is 1/2, and a half-life equals 6. So it says a half-life of 6 hours. So we can take all this information. Y is what we're going to be solving for, what we're trying to find. X is what is constantly changing, because that's the number of hours. And then 1/6x is the number of half-lives. So what does that look like in our equation? Here we have y equals 50 times 1/2 to the power of 1/6 times x. So we had a times b to the x. Alright. We can also put our values straight in, like you can see. We said 25 is what we were solving for. So we can decide that after 25 hours, 2.789 milligrams of titanium 99M remains. We will finish part 2 of this lesson tomorrow.